Poor shift quality, repeat failures, and unnecessary part replacement are common concerns, and even after service, the problem often returns. This does not occur by chance. Modern transmissions are no longer simple gearboxes, but complex systems that integrate mechanical components, hydraulic control, electronic systems, and adaptive strategies. Without a clear understanding of how these systems interact, service procedures remain incomplete and the root cause is left uncorrected. Accurate repair begins with understanding the system. Transmission controls how engine power is delivered to the wheels through the use of different gear ratios. Because an internal combustion engine cannot deliver sufficient torque at lower RPM, the transmission provides gear reduction to increase torque and output speed during vehicle launch and acceleration. By selecting different gear ratios, the transmission provides the required balance between torque and speed. Operation depends on engine speed, vehicle speed, and load conditions. Transmission issues often involve both mechanical wear and electronic control faults. Fluid condition is critical. Burnt or discolored fluid indicates clutch or brake band slippage, even in lifetime systems where oxidation and additive degradation still occur. Adaptive systems compensate for wear by increasing clutch apply volume. This is seen as an increase of duty cycle or pulse width modulation on the scan tool. When limits are exceeded, shift errors or DTCs result. Mechanical noise NVH also provides direction. Whining under load points to gear issues, while grinding during shifts indicates synchronizer or engagement faults. Accurate diagnosis requires a structured process. Begin with visual inspection. Check for fluid leaks and loose electrical connections. On ABS-equipped vehicles experiencing shift concerns, verify the wheel speed sensor signals for irregular patterns or signal dropouts. The system monitors clutch volume index, or CVI. Low CVI indicates minimal wear, while high CVI suggests excessive wear or sealing issues. When limits are exceeded, a DTC may set and the system may enter fail-safe or limp mode. Worn clutch packs or leaking seals are the most likely cause. Failure to perform a CVI relearn after a repair may compromise an otherwise successful repair by retaining learned values that are at or near their limits, which can mimic the original concern even though the issue has been corrected. Always check technical service bulletins, as some issues are resolved through software updates. Intermittent faults are often related to wiring connections or internal hydraulic issues, such as leaking seals and/or actuators. Late model transmission valve bodies often include integrated control modules. Used units are typically programmed to the original vehicle, and installing them on a different vehicle may create new issues not related to the original complaint. Following a logical 7-step diagnostic process is the best practice to identify the root cause. Verify the concern through a road test. Collect DTCs and check service history and technical service bulletins. Evaluate the evidence, review scan data, and perform targeted tests. Perform the appropriate repair, replace parts, or complete software programming as required. Finally, validate all shifts are smooth and confirm no faults are present. Prior to performing a quick learn, ensure no DTCs are present and transmission oil temperature is within specification. Otherwise, the procedure may be aborted. Effective transmission service requires accurate documentation and specialized equipment. Service information, including manuals, wiring diagrams, technical service bulletins, and calibration procedures, must be consulted before any service. Electronic diagnostic tools are required to evaluate control logic and sensor feedback. Scan tools provide access to TCM live data, flight data recordings, and guided service functions or relearn procedures. Advanced test equipment such as oscilloscopes or graphing multimeters support analysis of sensor signals, solenoid control, and communication integrity, especially for intermittent faults. Basic DVOM, digital volt-ohm meter, are used to verify power supply, ground, and circuit resistance. Hydraulic testing equipment allows comparison of actual pressure to expected values, along with mechanical inspection for related components. Proper fluid service requires equipment for draining, filling, and level verification. Tools to measure temperature, either through scan data or external probes, are necessary because many transmissions require fluid level checks within a narrow operating temperature range. Accurate temperature awareness is critical to prevent overfilling, underfilling, or misdiagnosis. Modern transmission service requires system state analysis. Mechanical, hydraulic, and electronic subsystems continuously interact, and diagnosis must address why the system responds the way it does. Not all shift concerns are mechanical. Control logic adapts shift pressure, timing, and clutch operation, and calibration or data issues can mimic mechanical faults. Operation depends on shared inputs such as driver demand, engine speed and load, manifold absolute pressure and/or MAF calculations, brake switch and vehicle speed signals. Faults in these signals can affect transmission behavior even when internal components are functioning correctly. Solenoids control hydraulic pressure and clutch application, and faults can create repeatable gear-specific issues. Erratic shifting can vary depending on temperature and operating conditions. During diagnosis and repair, ensure testing is performed under the same conditions in which the issue originally occurred. A technician's most valuable asset is the integrated insight into how hydraulic, electronic, and mechanical systems converge. This integrated expertise is the cornerstone of an effective diagnosis and a lasting repair. Learn more at pro.repairsolutions.com.